Okay, guys, so let's go to topic 1.7, part 5. And remember, this is properties of logarithms and rational exponents. Okay, so let's go into the part 5. In the previous part, I showed you how to solve exponential equations by using logarithms. And now we're going to go into solving logarithmic equations. I'm going to show you 6 examples, and you're going to see how this is extremely simple once we know and understand the properties of logarithms, okay? Which so far we have proven 7 of them. So have them by your side, and let's start. So the first example is this. You're going to see how simple this is. The first example is logarithm base 7 of x minus 1 equals logarithm base 7 of 3 minus x. This looks complex, but it's not. It's extremely simple. Why? Because we have the logarithm base 7 of this number being equal to the logarithm base 7 of this other number. And remember, if the bases are the same, then the numbers obviously have to be the same. It's like this. If we know that x equals y, then the logarithm base a of x equals the logarithm base a of y, right? And now this is about going backwards. If you know that log base a of x equals log base a of y, then x equals y. So we're doing exactly the same thing. Basically, we have this x minus 1 equals 3 minus x. And now we can solve this extremely simple equation. I give you some seconds to solve it, and then look up to check your answer. And there you have it. The answer is x equals 2. First example, extremely simple. Okay, example number 2. Log base 2 of 5 minus x squared equals 2. Okay, so how do we do this? How do we solve this equation? Okay, very simple. We have to understand what all of this means. And basically, go back to the exponential form. Remember, if log base a of x equals y, that's because a to the y is equal to x. A to the y is equal to x. So I'm gonna apply that stuff right here. If log base 2 of this number is equal to 2, that's because 2 to the 2 is equal to this number, right? And so this equation is completely equivalent to this equation. And this equation is extremely simple to solve. 2 to the 2 is 4. And then we do some algebra. Right? You see, it's extremely simple. So this is the answer. I give you some time to copy or finish the equation. And now let's move on. Now, why did I write this plus and minus? Remember that when you take the square root of a number, you have to have both answers, the plus and the negative answer. Let's go to example number 3. Let's write log of x equals 2 minus log of x minus 2. Let's copy. Okay, so how do we start this equation? We can start this equation in the following way. I need you to have all the terms with logarithms on one side of the equation. So I'm going to bring this one to the other side in this way. Okay, perfect. Now, look up at your list of properties of logarithms and look at property number 4. And we can use it in order to simplify all of this. Okay, all of this will be the same as log of x times x minus 2 equals 2. Make sure to understand why this is equal to all of this. I'm going to write that property in here. That property said that log base any number of, of x times y is equal to the sum of the logarithms independently. So all I'm doing is going backwards. What I have in here is this, and I'm going backwards. Can you see? Okay, let's continue. So remember what this means. Log without any number in here, that means logarithm base 10. So I'm actually going to write it. If you write it or not, it doesn't matter. It is the only base that can be ignored. The only base. So we have this, right? And like in the previous example, all we have to do is rewrite this in its exponential form. Log base 2, base 10 of all of this number equal to 2. That means that 10 to the 2 is equal to all of this. Okay? And now we have a very simple equation to solve. 10 to the 2 is 100. Then we multiply these two parentheses. Okay? Then I rearrange these terms. So this is going to be equal to x squared minus 2x minus 100 equals 0. Make sure that you understand what I did. I give you some seconds. And finally, this is solved by the general formula. Okay, this is going to be minus 2 plus minus 2 to the squared minus 4 times 1 times minus 100 over 2 times 1. That's it, okay? The rest is just arithmetic. It's about doing all of this and so on. But basically, the equation is solved because we have found the solution, right? It's all of this. Try to see this as a simple number, just like 3. just written in a more complicated way. We have found the solution because we have already isolated x. I leave this for you as homework. Let's move on. Okay, equation number 4. Let's write 2 log of x minus log of 2x minus 1 equals 0. Again, all of this looks very complicated to your brain because you have a lot of things going on, logarithms and multiplications and so on, and you're not used to working with this. But these things are extremely simple, and I'm going to show to you why. First, look at this part. How can I simplify this? How can I use one of my properties to change this? Okay, look at property number 6. Property number 6 is this one. Okay, and I'm gonna use it in order to rewrite this as this. Can I do that? Yes. Make sure to understand why this is the same as this according to this property. Basically, what I'm doing is going back from this to that. Can you see? Perfect. So I'm gonna first do that. I'm gonna write this as this. And you're gonna see why I did that in a moment. Okay, now we have the subtraction of two logarithms with the same basis. And so I can make use of the property number 5, which is this, the logarithm base a of x over y equals the logarithm base a of x minus the logarithm base a of y. And I can use this property and go backwards because what I have here is a subtraction of logarithms with the same base. So basically I have this, and all I need to do is go backwards. So I can write all of this simply as the logarithm of x squared over 2x minus 1. Make sure to understand what I did. What I did. Very well. Let's continue. Now, I'm gonna remember this. There is a little 10 here. There is a small 10 that is ignored. I'm gonna write it down. If you feel more comfortable either writing it or not writing it, that's perfectly fine. There's nothing wrong about that. Okay, so this is the same as this. And remember that we can go back to the exponential statement equivalent to this, right? Logarithm base 10 of this number equals 0 means the same as 10 to the 0 being equal to all of this. Okay? And now we have this equation which is completely equivalent to this. If we solve this equation, then that means that we are solving this without knowing it, so to speak. So 10 to the 0, any number to the 0 is 1 equals x squared over 2x minus 1. We multiply both sides times 2x minus 1. And now we have this simple equation. It's extremely simple. I give you 1 minute to solve it. Go ahead. Okay, if you found that the answers, there are two, are plus 1 and minus 1, you are correct. Although for technical reasons that I will also explain later in the chapter of functions in the second block, we're gonna ignore the negative answer. Okay, make a mental parenthesis right now. We're gonna ignore this solution, x equals minus 1. The reason is this, that if I take that solution and if I put it right there in my equation, that is 2 times the logarithm of minus 1 minus blah 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 equals 0, that's gonna blow up. Why? Because we cannot calculate the logarithms of negative numbers. Okay, we don't want to do that. I will explain that later. Okay. Okay, fine. So let's go to the fifth and final example, which is this: the logarithm base 10 of the logarithm base 10 of x equals 2. So look at this. It looks complicated, right? It's not, guys. When you understand things, these things are not complex. Okay, so let's see what we can do in here. So first, remember, if you feel comfortable, write the base. That's perfectly okay. So first, I'm gonna do this. This is a number, right? Try to see this as a simple number. Don't look at what's inside. Logarithm base 10 of x. No, try to see this as circle, so to speak. Logarithm base 10 of circle equals 2. Okay, I'm gonna write its exponential form. If logarithm base 10 of circle equals 2, that's because 10 to the 2 equals circle. And I'm going to write precisely that. 10 to the 2 equals circle. Okay? But what was circle? Circle was logarithm base 10 of x. And let's continue with this equation because it's completely equivalent to this one. 10 to the 2 is 100 equals logarithm base 10 of x. And then if you want, change the sides. I always feel more comfortable working like this than like this. I don't know why. That's a very weird phenomenon. Okay, so now we have logarithm base 10 of x equals 100. And I'm going to apply the same property the same method that I did here. If logarithm base 10 of x equals 100, that's because 10 to the 100 is equal to x. And we're done. Can you see? We have isolated x. X equals 10 to the 100. Of course, don't even try to raising 10 to the 100, okay? That's a lot of zeros. But this is enough. This is a perfectly fine answer. X equals 10 raised to the 100. Actually, it's practically impossible to write it. No, it's not that large. You can actually write this number. I just don't recommend it. So that's it. Okay, so that's how we solve these equations. Don't be afraid of looking so many logarithms and so on. Take your time, be calm, use the properties, and in the end, if you try and try and try and try to solve an equation, and if you fail, you can always look for help. Okay, don't get desperate. That's the idea. Okay, thank you guys.